So now we're going to learn how to solve polynomial functions by factoring. Right, so just an introduction to what polynomial functions are. So we've actually been working with polynomial functions of degree 1 and then degree 2. So and degree 0. So a polynomial function, let's go through them. So if we have y equals c, where c is a constant, the degree is 0. Technically you've got x raised to the 0 power is 1. And you have a constant or horizontal line. If you have y equals ax plus b, right? A, of course, is the same as m, our slope. Your degree is 1 because x is raised to the first power, and you have a linear function. If you have y equals ax squared plus bx plus c, right? Your degree is 2 because that's your highest exponent, and it's quadratic, and that's what we've been working with. So now let's add to that. If our highest term is a cube, then we have a cubic function. It's degree 3. If our highest exponent is a x to the 4th, we have degree 4. It's a quartic function. And then if our highest exponent is a 5, it's degree 5, and it's a quintic function. So the largest exponent within the polynomial determines the degree of the polynomial. These are examples. So here we have examples of polynomials. Here are some examples of functions that are not polynomials. So f of x equals the absolute value of x plus 2. That's an absolute value function. G of x equals the square root of x minus 1. That's a radical function. H of x equals 2 to the x, which is exponential. I of x equals x plus 2 divided by x. That's rational. J of x equals log x. That's a logarithmic function. So anytime we have any functions that are within our equation, like a log, or if we have an expression under a radical, or a variable in a radical, or a variable in an exponent, or a variable in a denominator, any of these things, that makes our function not a polynomial. And we're not working with those in this particular lesson. So comparing factor solutions and zeros, you do have to know the difference, and know that if x plus 5 is a factor, then if I plug negative 5 into the equation, I would get 0 because negative 5, 0 is an x-intercept. It's one of our solutions. It's one of our zeros. Right? So if x minus 3 is a factor, then if I plug in 3, f of 3, I get 0 because it's an x-intercept. And the value of y on the x-axis is 0. Right? So you do need to know that if something is a factor, right, it's going to result in us having a 0 and be an x-intercept. And if I plug that value in, I get 0 out. Right? And we can see the value of y when x is negative 5 is 0. That's right. It's right there with our point, negative 5, 0. Right? So make sure you understand that little relationship. So a polynomial of n degree has n roots. So the degree equals the number of solutions. So if we have y equals x squared, our exponent is a 2. Right? So a quadratic function has 2 roots. A cubic function, y equals x cubed, has 3 roots. So the number of solutions equals the degree, and the degree equals the largest exponent. Right? So it's easy to know how many solutions you're supposed to have. And of course, linear is degree 1, so it only has 1 solution. Recall the zero product property. If a times b equals 0, then a equals 0 or b equals 0. So we want to find the zeros of the following polynomial. We see we have 4 factors. Right? We have x minus 2, we have x plus 3, x minus 5, and 2x minus 13. Right? It's all factored. We have 4 solutions. So therefore, this is a quartic function. It's got 4 solutions. So those are our factors. Our solutions, our roots, are going to be x minus 2. So if x minus 2 is equal to 0, x equals 2. That means that f of 2, if I plug that in, I would get 0 as an answer. So we have another factor, x plus 3. If we set x plus 3 equal to 0, x equals negative 3 is another x-intercept, another solution. And that does mean f of negative 3 gives us 0. If we have x minus 5 is a factor, that means that if we set x minus 5 equal to 0, x equals 5 is another solution. And that does mean f of 5 equals 0. And finally, if we have 2x minus 13 equals 0, you'd add 13 to both sides, divide by 2, so 13 halves, or if you like, 6.5 is another solution. So f of 13 halves gives us 0. So there are 4 real roots here, negative 3, 2, 5, and 6.5, or 13 halves, all with a multiplicity of 1. Multiplicity just means how many times a factor appears. When we get to graphing polynomial functions, we'll talk more about that. And so because we have 4 solutions, by the way, we know this is quartic. It's y equals x to the 4th something. X to the 4th plus something else. If we want to know the whole function, well, we have it in factored form, right? So it would be, we have an equation in factored form, but if you wanted it in standard form, you'd have to multiply those all back out together again. And it's more effort than it's worth, because it's perfectly fine in factored form. So what are the zeros or solutions of the following polynomial? Right? So we have x minus 2 times x minus 1 times x minus 3 times x minus 4 equals 0. So those are our factors. If x minus 2 is a factor, 2 is a solution. And that means 2, 0 is an x-intercept. And f of 2 equals 0. X minus 1 is a factor. That means x equals 1 is a solution. 1, 0 is an x-intercept. And f of 1 equals 0. If we have x minus 3 as a solution, as a factor, then x equals 3 is a solution. 3, 0 is an x-intercept. And f of 3 equals 0. And finally, if x minus 4 is a factor, then x equals 4 is a solution. 4, 0 is an x-intercept. And f of 4 equals 0. All right, so there will be questions just on knowing the relationship between factors and solutions. So sometimes polynomial functions can be factored using the same techniques as quadratic functions. And that's what this part of the lesson will be about. Greatest common factor is an expression of the highest degree that divides each term of a polynomial. So a greatest common factor, a GCF, is a term that all of the terms in our equation are divisible by. So we're going to learn how to factor a greatest common factor or a monomial from a polynomial. So you determine the greatest common factor of all the terms in the polynomial. You're going to express each term as the product of the GCF and its other factors. Make sure you divide each term by that greatest common factor, or if you have said something incorrectly. Right? So if you're multiplying by the greatest common factor, you have to have divided it out from each of your terms. You'll use the distributive property in reverse to factor out the GCF and factor the remaining expression if possible. Sometimes there'll be something more you can do. Sometimes it's all factored. If you don't have anything to a higher power than to the first power, then you're done. All right, let's take a look at this. All right, so we have 3x to the 4th minus 18x cubed minus 21x squared. So all 3 of those are divisible by 3, and they're all divisible by at least an x squared. Right? So now let's divide all of our terms by 3x squared. Now as soon as I write that down, in the parentheses has to be those terms divided by 3x squared. So 3x to the 4th divided by 3x squared is going to be x squared. Right? And if you're not sure, I'll put it over here. So 3x to the 4th divided by 3x squared. The 3's would cancel. So now I've got x times x times x times x in the numerator and x times x in the denominator. You can cancel out 2 x's in the numerator and denominator. That's why that's x squared. All right, so 18x cubed divided by 3x squared. 18 divided by 3, that's going to be 6, and negative 6 because of the subtraction sign. X cubed divided by x squared, that's going to be an x, right? Because you would have, and I'll write that out, 18x cubed divided by 3x squared, right? So They're both divisible by 3, so you have the 6, but there's a subtraction sign. And then the rest would be x times x times x over x times x, and so you could cancel out 2 x's. Or 2 factors of x, I should say. And then 21x is going to be subtraction sign. 21x squared divided by 3x squared. All right, that's just going to be a 7 because all the x's will have canceled. We can factor the rest. All right, so I'm going to just put this over here. 3x squared, that's one of our factors. Let's factor the rest. All right, so we have x squared minus 6x minus 7. And now we're just going to use our factoring techniques. Do not use anything other than factoring unless it is absolutely not factorable, and you really aren't going to see too many of those. All right, so 1 times negative 7 is negative 7. We need two numbers that multiply to give us negative 7. Add to give us our b term of negative 6. So that's going to be negative 7 and 1. So we have x squared minus 7x plus x minus 7. First to our group, second to our group. Oh, and we're setting that equal to 0 because we're solving. All right, so we'll factor out an x from both terms. Then we have x squared divided by x is x. Negative 7x divided by x is a negative 7. And notice the only common factor here is a 1. We can factor out our repeating x minus 7. That's one factor. If we factor out an x minus 7, the first term would just be an x. In the second, it would just be a 1. And there we go. Now we're factored. So now we can set our factors equal to 0 and solve. So the only new thing is we had to factor something else out first. So 3x squared equals 0. Well, you divide 0 by 3, it's still 0. You take the square root of 0, it's still 0. So x equals 0. And then we have x minus 7 equals 0. So we would add 7 to both sides. X plus 1 equals 0. Subtract 1 from both sides. X is negative 1. Now let's check. This is a x to the 4th. Right, so this is degree 4. We need 4 solutions. Do we have 4 solutions? I only see 3. Never fear. This one is multiplicity 2. Why was that one multiplicity 2? Because it's an x squared that's 0. So we have 2 factors of x that are 0. And if you think about it, an x equaling 0 and an x squared equaling 0 are very different things, right? If we have the graph of y equals x, right, that's just a line. But y equals x squared, that's a parabola. Right? So this one is multiplicity 2 because there's 2 factors of x. If there's an x squared that's equaling something, then there's 2 of that something. So there's 2 zeros there. Right? So our x-intercepts, technically, or our solutions, we'll just keep it to solutions right now. Our solutions are 0, 0, and 7 and negative 1. Right? Because this one is multiplicity 2. Right? And if you have a squared, then it's going to be multiplicity 2. Or if you have 2 of the same factor. All right, let's take a look at this one. Factor out our greatest common factor. Well, here, our greatest common factor is just an x. All right, so we'll factor out the x and divide everybody by x. So we're going to have 15x squared minus 2x minus 1. All right, and now we can factor the rest. All right, so we have 15x squared minus 2x minus 1. All right, multiplies to give us negative 15, because 15 times negative 1 is negative 15. Adds to give us negative 2. Well, 15 doesn't have too many factors. This one is going to be negative 5 and positive 3. So the x is going to come down here. We've got a 15x squared. We're going to replace the negative 2x with a negative 5x and a positive 3x, because that's what it was before somebody multiplied it together, right? First to our group, added them together. Second to our group, we'll factor out a greatest common factor, so we can factor out a 5x. 15x squared divided by 5x is 3x. And then negative 5x divided by 5x is going to be a negative 1. And notice we're going to factor out a 1. Right, so now we can factor out our repeating 3x minus 1. If we factor out that repeating, we're left with 5x from one term and 1 from the other. And there, we're done. And this should have said equal to 0 the whole time. So now let's just set our factors equal to 0. We've got x equals 0. We have 3x minus 1 equals 0. So now we would add 1. 3x is equal to 1. Divide by 3, x is 1/3. And 5x plus 1 equals 0. Subtract 1 from both sides. Divide by 5. X is, lost an equal sign there. There we go. X is equal to negative 1/5. And there we go. So we are degree 3, because it's an x cubed. So we're going to have 3 solutions, and we do. So all of those solutions are multiplicity 1, because we weren't setting any squares equal to 0, just linear factors. All right, let's go on to the next one. There's only a few of these. Actually, I have 1, 2, 3. Let's do 3 more in this podcast. All right, and was it this one? No, yes, it was this one. All right, so our greatest common factor, they're all divisible by x squared. They don't have any other coefficients in common. So our greatest common factor is x squared. We'll factor an x squared out of everybody. All right, so now we'd have a 9x squared minus a 10x and plus a 1, right? Because x squared divided by x squared is just 1. All right, so now this one can come down here. X squared equals 0 is one of our factors. So we know that we have 2 factors of 0. Sorry, I meant to put multiplicity 2 there. All right, so let's factor the rest. 9x squared minus 10x plus 1. 9 times 1 is 9. We need 2 numbers that multiply to give us 9, but add to give us negative 10. Well, it's got to be negative 9 and negative 1. So we replace the negative 10x with a negative 9x and a negative 1x. And the first 2 are a group and the second 2 are a group. We'll factor out the 9x. So 9x squared divided by 9x is x, and 9x divided by 9x is 1. From here, we're going to factor out the negative 1 because we need it to be x minus 1. Now we can factor out the repeating x minus 1, and the leftovers are left, 9x minus 1. Oh, and I keep forgetting to put equals 0 because we are solving. And so now our last 2 factors, x minus 1 is equal to 0, so x is 1. 9x minus 1 is 0. We will add 1 to both sides and divide by 9. So 1/9 is the other. There's our 3 solutions. Well, technically 4, right? 0 counts for 2, 1, and 1/9. Right? And so this is just like we did before with the factor by grouping, right? Except we just have to factor out a common monomial first. Right? So let's take a look at this one. And I wrote it so pretty for you. And I'll try and keep to the colors there. All right, so here we're going to factor out the greatest common factor, which is a 3x squared. All right, so if we factor out a 3x squared, we're going to be left with a 2x squared, right? Because 6 divided by 3 is 2. X to the 4th divided by x squared is x squared. You just subtract exponents when you're dividing. And you add when you're multiplying. 18 divided by 3 is a 6. X cubed divided by x squared is an x. And then 15 divided by 3 is 5. X squared divided by x squared, we got more x squareds. Right? So we have one solution. We have the 3x squared. Right? So I have it over there. So 2 times 5, that's 10. Multiplies to give you 10, adds to give you negative 6. Oh, there's no such number. That's not factorable. So let's solve another way. And this time let's use completing the square. All right? As practice. You won't come across too many of these when you're solving them. All right? But here's one for our notes. So the 3x squared is already at the bottom. We're just going to deal with this. Right, so we've got 2x squared minus 6x plus 5 equals 0. It's a good chance for me to review completing the square. We got to divide everybody by 2 because a has got to be 1 for completing the square. Otherwise, we won't have a perfect square. So we have x squared minus 3x plus 5 halves. Not the prettiest thing in the world. We're going to subtract 5 halves from both sides and move the constant term. So we have x squared minus 3x, and I'm going to leave a space, equals negative 5 halves. We're going to add b divided by 2 to both sides. Right, so that means we're going to add negative 3 divided by 2 squared. Sorry. So buzz, buzz, buzz divided by 2 squared. I do it over here, plus negative 3 divided by 2 squared. So now I've got x squared minus 3x plus 9/4. This side follows a pattern, right? So it's going to be x minus half of the exact same thing right here that I squared before I squared it. X minus 3 halves squared. So it's going to match. Equals, now we'll just add those together. It's going to be negative 5 halves plus 9/4. I need to change that 5 halves. So 5 halves is the same as 10/4. Right? Just multiply them both by 2. So negative 10/4 plus 9/4 is going to give us a negative 1/4. So we have x minus 3 halves squared equals negative 1/4. We'll take the square root of both sides. Don't forget your plus or minus. And I would split that up. And let's move this little term over here. So here we have x minus 3 halves, so the square and square root cancel. That is a perfect square, but it's a complex number. Square root of negative 1 is I, and the square root of 4 is 2. Right? And so then we would add 3 halves to both sides. So we have x equals 3 halves. Oops, what happened to my plus or minus? 3 halves plus or minus I over 2. Or you can write it as 3 plus or minus I all over 2. So we have two kinds of solutions here. We have real and complex. 2 real, 2 complex. So this would be x equals 0, right? That counts for 2. And because that plus or minus, that counts for 2 as well. So here we do have where something to the 4th, we're degree 4. So that means 4 solutions, which we have. We have 2 real, and move this out of my way. There we go. 2 real. You can't see what I'm moving, but it's a recording box. Here we go. Whoops. 2 real and 2 complex, and now I've got a box. That's how I know, by the way, my recording box tells me as how I know how long I've been recording. All right, so here we'd have 2 x-intercepts, the 2 zeros, and actually that's going to be 1 x-intercept, multiplicity 2, and we'll talk about that when we get to graphing, what that looks like. And then we have these 2 complex solutions, which don't show up at all in terms of a solution, but they do kind of create a little curve in our graph. So if we wanted to make sure that this was factorable or not, we could take the discriminant. So remember, the discriminant is b squared minus 4ac. That would give us negative 6 squared minus 4 times 2 times 5, which would be 36 minus 40, or negative 4, which means 2 complex solutions, and that's what we got. Right? So now moving on. Let's do this one. Nice, easy one. Ooh, nice and easy. Our greatest common factor, just an x, right? They're all divisible by x. That's it. So we're going to factor out the x. We'll have x squared minus 3x plus 2. This is a nice, easy factor. I'm going to move the x down here. Oh, I guess I said identify the greatest common factor, and I did, but then I just went and factored. There we go. Now I'll match my spaces there. All right, now we'll factor the remaining trinomial. So we have, and we're solving equals 0. X squared minus 3x plus equals 0. So 1 times 2 is 2. Two numbers that multiply to give us 2, but add to give us negative 3. They both got to be negative. Negative 2 times negative 1. Multiply to give us positive 2, and negative 2 plus negative 1, that's negative 3. So we have x squared minus 2x plus negative x plus 2 equals 0. First two are a group, second two are a group. We'll factor out an x, and I've got an x minus 2. Factor out a negative 1, and that will give us x minus 2. All right, so that repeating, we can factor out. And if we divide out the repeating, we're left with an x minus 1. And so our three solutions, we have x equals 0. So x is just 0. Let's move it down just a little bit. Come on, there we go. All right, x minus 2 is 0. So if x minus 2 is 0, x is 2. And finally, x minus 1 is 0, x is 1. And there we go. They're all factored. There's our three solutions. So this is degree 3. So we're expecting 3 solutions, and that's exactly what we got. 3 solutions. And there we have some space so you can actually read them. I think I have maybe one more. Oh, I have no more. All right, so in the next lesson, you'll see factor by grouping. And it's a lot like factor by grouping for quadratics, except you have one less step, which is nice. All right, so bye for now.